1999, scientists stumbled upon a hidden cosmic gem some 40 light-years away from us. TRAPPIST-1, a red dwarf star. Little did they know how lucky they were. 17 years later, our telescopes revealed the star's first planets. And the very next year, we uncovered 4 more planets orbiting the M-type star. Today, TRAPPIST-1 is the most studied planetary system aside from our own. Its 7 worlds are all rocky, strikingly similar in mass and size to our home planet, and some possibly containing more water than the Earth's oceans. For a very long time, scientists struggled to study distant worlds, but a lot has changed since the James Webb Space Telescope came into operation. So, how habitable is the TRAPPIST-1 system? And what would it be like to live on one of its worlds? Let's find out this and more around distant exoplanets. The telescope's near-infrared spectrograph and the mid-infrared instrument are able to measure a different spectrum of light emitted by faraway celestial bodies. The problem is, TRAPPIST-1 is an M-type red dwarf, which are the most prevalent in our galaxy, and the most active stars we know of, emitting powerful flares several times a day. And since studying an exoplanet's atmosphere takes observing light as it passes through it, it's difficult for scientists to distinguish ordinary light from the stellar radiation caused by the flares. And light bulbs, and seeing 4 of them being turned off. So what has the telescope discovered about the TRAPPIST-1 system so far? Recent observations showed that the closest planet to the star in the TRAPPIST-1 system either has a very thin atmosphere or none at all, and is most likely a bare rock. This innermost planet, called TRAPPIST-1b, is a scorching hot rocky world with a blistering surface temperature of 450 degrees Fahrenheit. The planet is too close to its parent star, much like Mercury in our solar system, which places it outside of the habitable zone. Slightly farther out, another planet rotates around the red dwarf, TRAPPIST-1c, 0 indicating that all incoming radiation is absorbed by a perfectly black surface, and 1 indicating that all incoming radiation is reflected by a perfectly white surface. The Earth. In the past, it was believed that the second planet in the TRAPPIST-1 system was similar to Venus, but the data from James Webb Telescope proved scientists wrong. The planet doesn't have a Venus-like thick atmosphere. And while the temperatures on the day side of this world are still extremely hot, about 225 degrees Fahrenheit, it is now considered the coldest rocky planet ever studied using this new method. In such harsh conditions, water would have evaporated long ago, even if it was initially present on these worlds. But according to a new study, the rest of the planetary system might have stayed cold enough for water to remain there, either in liquid or frozen form. The lightest of the planets in this system, TRAPPIST-1d, has around 30% the mass of the Earth and a radius of approximately 80% of our planet. Because of such small mass, the planet probably doesn't have a dense atmosphere or an abundance of heavy elements, but it still bears similarities with Earth, such as the amount of solar radiation it gets from its star. Located just on the inner edge of the habitable zone, the planet's temperature without an atmosphere would be about 48 degrees Fahrenheit. To compare, if there were no greenhouse effect on Earth, the surface temperature would be freezing, about 0 degrees Fahrenheit. But what's exciting about this world is that it could harbor a staggering 250 times more water than our own planet. Although the planet's potential habitability remains uncertain, but there's one factor that might change this. It's known as albedo, which is a measure of the reflectivity of a surface, typically expressed as a percentage. It quantifies how much incoming solar radiation reflects. Average albedo is 0.3. And so if TRAPPIST-1d has the same or similar value, it could provide an environment suitable for some forms of life. This is because water vapor acts as a greenhouse gas, but with Earth-like albedo, planets would escape the runaway greenhouse state. Scientists think TRAPPIST-1d is covered by a global ocean, but for life to thrive there, it needs a tidal heat flux 20 times stronger than what Earth has. Tidal heat flux is like a special kind of energy generated by the gravitational interactions with nearby celestial objects. On TRAPPIST-1d, this energy would act like geothermal heat that could sustain chemical reactions in its gigantic ocean. Some forms of life derive energy from chemosynthesis rather than photosynthesis, even here on Earth. So there's a possibility that TRAPPIST-1d could be a unique home for life that doesn't rely on sunlight. And if the planet has a thin atmosphere, its twilight zone, or the border between the night and day sides, could be habitable as well. Among the planets in the TRAPPIST-1 system, the fourth one, TRAPPIST-1e, is the most promising. It's both dense and possibly quite rocky, sharing similarities with our home planet, even in composition. Located in the habitable zone of its parent star, TRAPPIST-1e could hold a thick, oxygen-rich atmosphere, and all the hydrogen could have escaped its atmosphere because of how light it is, which is good news since it's a greenhouse gas. If TRAPPIST-1e began with more water than Earth and Mars and retained it on the surface over time, its climate could be strikingly similar to what we enjoy on our own planet. That being said, TRAPPIST-1e is considered one of the most Earth-like planets ever discovered. Imagine living in a world where a year lasts about 7 Earth days, and the concept of day and night is something completely different from what we're used to. Because of the close proximity to their star, all the 7 planets in the system are tidally locked, with one side always facing their parent star. During a never-ending sunset or sunrise, the sky would be a reddish hue, and you'd be able to see the 6 planets in the sky as if they were moons, with some appearing larger than the Earth's moon in the sky. On its day side, the planet might even have lands where humans could thrive. The climate would be much different. Thick storm clouds covering large areas, massive dust storms distributing heat across the planet, and maintaining a temperature balance necessary for complex ecosystems to flourish, while also generating powerful winds, tornadoes, and hurricanes. The night side would be a harsh place, even for expeditions. This is the realm of Arctic cold and towering glaciers that dominate the landscape. Although a constant twilight might get a bit tiresome, it offers a crucial advantage, especially for the first settlers. In the distant past, our ancestors used the ever-shifting constellations as direction guides. But on TRAPPIST-1e, a nearby star is always at a fixed position in the sky. So, it would be like having a permanent North Star to show the way through the uncharted territories of this alien terrain, although it would appear several times larger than the Sun. In our galaxy, there are 10 times more of these M-type red dwarf stars than stars like our Sun. These little red dwarfs hold promise as potential cradles for life, with trillions of years for life to evolve and flourish in their cosmic neighborhoods. However, as we mentioned earlier, even though they're normally dim, many red dwarfs can suddenly and dramatically increase their brightness. This supercharged mode is like a star shooting out solar flares on steroids. Some scientists think that the flares from the TRAPPIST-1 star might actually be helpful for life on the nearby planets. These flares give off a lot of energy, and that energy could have kick-started the creation of important molecules like amino acids, which are building blocks for life. So, while the high-energy radiation from flares could be harmful and may even sterilize a planet's surface or strip away its atmosphere, it could also provide the extra energy needed for early forms of life to develop. Although data shows TRAPPIST-1 is a much safer host star, its flares are about 30 times milder than those seen in other red dwarfs. But since the 7 planets in the TRAPPIST-1 system are tightly packed, the effects would be noticeable. And this means that auroras on TRAPPIST-1e would be nothing like the ones we know. Human bodies are fragile, so even weaker but frequent solar flares from the star pose a constant danger. Here, auroras act as natural alarms, signaling the incoming flare. To survive, inhabitants would rely on an exponentially thicker ozone layer and a strong magnetosphere, along with advanced technology to track and respond to these volatile solar events. For safety, colonizers of the planet could construct specialized shelters resembling bunkers. These shelters would be equipped with shielding materials and advanced life support systems, serving as a refuge during periods of intense space radiation, and they'd be built into every habitat. Moving wouldn't be much different, as the planet has gravity about 93% that of Earth. But if you don't find a safe place to hide once solar flares strike the planet, your arteries might contract, which can impair blood flow, leading to critical health problems. Exposure to this extreme stellar radiation can also damage the DNA within your cells, disrupting the normal cell production rate, causing mutations or a growth of abnormal cells. In this world of constant twilight, growing plants becomes a puzzle. The starlight reaches the planet's surface at a low angle, which can cast shadows and limit plant growth. To overcome this, humans might consider a concept like the hanging gardens of Babylon, letting vegetation drape from multi-level platforms to catch sunlight from different directions. Imagine a series of tiered planter boxes, each placed on top of the one below. Plants are spaced and designed to allow sunlight to filter down through the tiers. So, even if a plant on a lower level is partially shaded by the plants above it, it still gets some sunlight from the sides or through small gaps in between vegetation, making the most of the available sunlight. The idea is similar to the vertical gardens created by nature, where every inch of space is optimized for plant growth. If there's native flora on the planet, it might not need a human hand to thrive, since it has probably evolved to be completely black to absorb more of the sunlight. Another idea is some vegetation might also evolve into bioluminescent organisms, emitting their own soft glow to compensate for the lack of natural light. This adaptation would extend their growing hours and enhance their chances of survival in the persistent twilight. Located a bit farther from its parent star, TRAPPIST-1 F only receives about a third of the starlight compared to what Earth gets from the Sun. This makes this world much cooler. If there's no atmosphere around TRAPPIST-1 F, its surface temperature would be approximately -74 degrees Fahrenheit, turning any potentially existing water there into ice. The same would happen on the two outermost planets, TRAPPIST-1 G and H. Although the data shows they are rich in water, their surface will be covered in ice. However, since TRAPPIST-1 G is about 30% more massive than Earth, it could potentially hold on to its atmosphere. If the planet managed to preserve this heat-distributing layer and has active volcanism to fulfill greenhouse gases needed to sustain that atmosphere, the planet might still be a water world. Or maybe there's a subsurface liquid water ocean on this planet that hides exotic forms of life. If it exists, scientists speculate that the ocean could be 415 miles deep. To put this into perspective, the average depth of the Earth's global ocean is around 2.3 miles. The corner of the TRAPPIST-1 system, where the seventh planet orbits, doesn't get bathed in much stellar radiation. If the planet was orbiting inside our solar system, it would be somewhere between Mars and Jupiter. According to estimations, the surface of the TRAPPIST-1 H is a chilling -148 degrees Fahrenheit. TRAPPIST-1 is an aging star that's been cooling for 7.6 billion years since its birth. The nearby planets were once exposed to extreme conditions due to intense heat. In theory, this heat should have caused any water present on these celestial bodies to turn into vapor and concentrate in their atmospheres. Later, as extreme stellar winds hit the planets, this water would escape into space. However, astronomers have been working on more accurate models of planetary atmospheres based on real data. In the past, it was believed that heat escaped from a planet's surface through convection, a process similar to hot air rising and cold air falling. But celestial objects are more complex than that, and the gases in their atmospheres act differently at different altitudes. Recent research suggests that the TRAPPIST-1 planets might not have heated up enough to turn their crust and mantle into molten rock. This means that a significant amount of water might have remained trapped within the rocks, even after the star cooled down. Currently, the conditions on these planets might be extreme. Although red dwarfs are known for their remarkable longevity, And so, the 7 TRAPPIST worlds have billions and trillions of years to go through countless stages of evolution. Until one day, what is currently scorching or freezing turns into a more hospitable environment, teeming with life as we understand it. In the upcoming years, the JWST will uncover more about these Earth-like planets, so stay tuned here to not miss out on the biggest discoveries in space science. Let us know what you think about the potential for life in our cosmic neighborhood, and thanks for watching.